Radio at freedomslips.com. We'll be right back after this message. Thank you for listening to Revolution Radio at freedomslips.com. Any commercial advertising you may hear in this program is of the sole discretion and benefit of the host of whose program you are listening to. Revolution Radio does not endorse any commercial products, nor does it accept monetary compensation for on-air advertising of commercial products, nor will it ever. We are and shall remain 100% listener supported. Any product advertising on this program are considered used at higher risk, and Revolution Radio shall not be held liable for any claims or damages received from any product advertised within this program. Revolution Radio, where information never sleeps.
Thanks for tuning in to Revolution Radio. Here at Revolution Radio, we are listener-sponsored and commercial-free. But there still are bills to pay. In order to raise some needed funds to cover the cost, our station is offering a silver special. In the continental United States for a $60 donation, or in Alaska, Hawaii, or Canada for a $70 donation, we will send you an uncirculated 2018 1-ounce pure silver eagle. The $70 donation, the extra 10 is to cover shipping, by the way, outside of the continental United States. When making the donation, you must put Silver Eagle promo in the notes on the donation. And thank you for tuning in to Revolution Radio at revolution.radio and freedomslips.com. Without you, there is no us. Revolution Radio, where information never sleeps.
Take a look around, kid. What do you see? Homes being foreclosed. People working 2-3 jobs just to put food on the table and still drowning in debt. Don't get me wrong. This country was founded on great ideals and principles. They've all been ruined by the banks. Open your eyes to the banks that are robbing you. You know who my favorite president was? Oh, Thomas Jefferson. Because he saw all of this coming and tried to stop it. He fought the banks. JFK too, and they killed him for it. The banking institution is more dangerous than an army, he said. He also said that every generation needs a revolution, Jimmy. The American dream is just that. Just a dream. War is a continuation of politics, only by other means. Politics is a continuation of economics by other means. This is our bank. This is our war. And this is our plan of attack.
Banks have become an essential threat to our democracy. So consider this justice.
Thank you for listening to Revolution Radio at freedomslips.com, the #1 listener-supported radio station on the internet. Please help support this station so this battle can continue forward. Revolution Radio! The opinions expressed on this radio station, its programs, and its website by the hosts, guests, and call-in listeners or chatters are solely the opinions of the original source who expressed them. They do not necessarily represent the opinions of Revolution Radio and freedomslips.com, its staff, or affiliates. You're listening to Revolution Radio, freedomslips.com, 100% listener-supported radio, and now we return you to your host.
Let's try that. Do we have sound now? ABC. Test. 1, 2, 3, 5, 4, 3, 2, 1. Dead air. All the time. Testing. 1, 2, 3. Testing. 1, 2, 3. Testing. 1, 2, 3. My mic should be hot. My mic should be hot. We should be started. I see little disturbances. I do see something. It looks like my mic is hot. Once again, everyone, this is Francis Walsh, Collision Course, episode 4. 4 episodes in a row, having the hardest time getting on air. I hope that I'm going to watch my gauges that the sound is making it through to the station because we do have a lot of outer space to talk about tonight. Forgive me for the slow break into the show. I hope that everyone is ready for a little outer space news. Tonight is Amateur Astronomer Night in America on Collision Course. That's right. We are going to focus on some amateur astronomers tonight. Chris and Mark will come on in about a half an hour. We're going to investigate what makes a good amateur astronomer, and I feel like what we have in line are two very good amateur astronomers, the folks who can give us some insight into what's going on in the amateur astronomers' world. What gets them to where they are with astronomy, where astronomy is, and where it's going. And that's going to be the types of questions I ask and the type of discussion we're going to have with Mark and Chris when they get on air. Hopefully, because again, the half-hour breaks, I'm having a hard time breaking in at the half hours with everybody on board. So Collision Course stumbles its way on air again. I promised myself that I'm not going to do it to myself each week, and I do, unfortunately. But let's look right now. Get looking. Close your eyes. It's probably daylight out, wherever it is right now where you are, sunny, cloudy, light, or dark. We're going to close our eyes and look into outer space because that's where Collision Course does most of its business, in the darkness outside our atmosphere. Always of interest are the close approach near-Earth objects coming in over the next upcoming so many days. We go from October 29th to November 28th with a list of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 objects. We'll start right off the bat on October 29th, 11:59. 2006, the Discovery 2006 TS7, coming in as close to 7.51 lunar distances. Remember my number whenever I think of the moon's average orbit in the 238,000 mile range. It isn't a perfect circular orbit. It does have a perihelion to Earth, and an apogee. So in this case, 2006 TS7 coming in 7.51 nominal AU, size 150 meters, magnitude 21.12. Magnitude, if you don't know, magnitude represents the brightness of the object. Our eyes will see a magnitude of objects in the night sky from 1, 2, 3, 4, 5, 6. 6 is where our eyes will reach their maximum. You'll use some binoculars, and you might go magnitude 7, 8, 9, and then you'll have to start going into telescope views as you go into magnitudes 10, 11, and 12. And your ability to see dimmer objects will increase with the type of telescope that you're using, because you'll have to increase things like aperture and focal speeds to catch the types of magnitudes you may be going after. And so we started with the top one being a magnitude 21. So a medium, actually even a 21 Yes, a medium size telescope could go after that one. 2018 UC is the next one on October 30th, the day before Halloween, coming in at 5.38 lunar distances, speed 9.32 kilometers a second. First one was coming in at 18.11 kilometers a second. This one's coming in at 9.32. Magnitude 26, so that one's dimmer than the first one at 21.2. This one's even dimmer at 26. Diameter 17 meters. The next 2018 UY1, November 4th. We have two coming in at November 4th. 2125 is the first one, 2144. So they're only so many minutes apart. 2018 UY1 comes in at a lunar distance minimal of 7.42, speed 8.31 kilometers, magnitude 24 meters. Then you have 2002 VE68 coming in the same day, so many minutes later. Its lunar distance is 1465, speed at 8.63. So they're both moving at relatively the same or very close speeds. These are the types of objects, when you have groupings like this, that may or may not be affected by another object. I don't know the dynamics of each of their orbits, so I don't know that. But I wouldn't doubt with something so close to each other, they must have some sort of resonance in between the two objects. One being a 20.5 magnitude and the other being a 20.4. They're both nearly the same size, one at 210 meters and one at 230 meters. One discovered in 2002, one discovered in 2018. Yes, interesting. The next object for the next day, November 5th, 2018, TF3, lunar distance 7.77, speed 20.60 kilometers, magnitude 20. Now we're getting some of your smaller telescopes might be able to pick this up if you know exactly where to look and you happen to have perfect conditions, 230 meters to 510 meters. So it's kind of got some size to it as well. The next object, 2010 VQ, comes in November 7th at 15.56 lunar distances. The speed is slow at 3.86 kilometers. The magnitude is low at 27.7, and it's small at 7.7 meters. Next object, 2018 UQ1, November 13th. We have a nominal distance. What are we at? UQ1 nominal distance of 9.40. Kilometers 12.34, magnitude 21.9, size 110 meters. Moving on, WB105, discovered in 2009, coming by on November 25th, 15 lunar distances, 18.88 kilometers, and 23.5 magnitude at 53 meters. Not too big, rather dim. WD14, discovered in 2018, comes by November 27th, 7.42 lunar distances, 9.30 speed in kilometers, and 22.9 in magnitude, 70 meters in size, not too big either. Last one, WO15, discovered in 2001, comes flyby at November 28th, 1360 lunar distances. I'm going to look at this one. It says nominal lunar distances, AU, 13.60, and then it says the minimum lunar distances at 2.95. I'm looking up the scale, and most of the two nominal to minimum all are close together. I'm looking at 2001 WO15 flyby November 28th, 2016. Nominal distance lunar 1316, minimum 2.95. So there's something to investigate in there. Why that orbit isn't. What's the word I want to say? Imbalance with each other. Okay. Speed 11.69 kilometers, 22 mag. Medium-sized telescope could reach out and get that 80 meters to 180 meters. All right, there's the list. Of course, we get to the last one. There is a little bit of intrigue in that the two nominal and minimal distances are 11 lunar distances apart from each other. Interesting. On the news feed from the North Holt Branch Observatories, dated October 25th, 1:22 p.m., near-Earth asteroids 2018 TQ2 and 2018 UA1, and in their images, a nice background galaxy. 2018 TQ2 is an armor-type asteroid with a diameter of 130 to 280 meters. It was first observed, Pan-STARRS first observed it, Haleakala on October 5th, and it made a close approach on October 26th, that was yesterday, at a lunar distance of 0.056. So we take 238,000 miles and divide it by 0.056, and you get, well, actually, that's incorrect in my point, because they're doing AU and not lunar distances. So when I said that was incorrect. It's 0.056 AU, and AU being 93 million miles, 0.056 AU is 8.3 million kilometers from Earth. 2018 TQ2 is currently visible at 17, which is a relatively bright object compared to our list of incoming that have a range of about 20. By chance, 2018 TQ2 was close to the famous Silver Sliver Galaxy, also known as NGC 891. When they made their observations, NGC 891 is an edge-on spiral galaxy, 30 million light years from Earth. It has a prominent dust lane, and you can see it in their image. It's made it a favorite target for deep sky astrophotographers, who we're going to be talking to in a little bit. And I'm going to break out the list of deep sky objects that are going to be great for November. NGC 891 looks very similar to what our own Milky Way would look like when viewed edge on. And in fact, the two galaxies are very similar in size and shape. 2018 UA1 is an Apollo-type, potentially hazardous asteroid with a diameter of 360 to 790 meters. It was first observed at Atlas HKO Haleakala on October 17th, 2018. UA1 made a close approach on October 5th at a distance of 0.093 AU. Again, those are AUs, not lunar distances, so it was a 13.9 million mile away pass from Earth. Now it is observable at plus 18 mag and fading. North Holt Branch Observatories noted that they are making progress testing the new QH-Y42 camera. They're hopeful to have it fully operational soon. Those cameras are going to take them a great way in their ability to take sharp images of the objects that they want to. That comes from the Facebook feed. Tonight we have a lot of different sources for news. 5:15 in about 20 minutes after the break, after the half-hour break. Hopefully we're going to get the half-hour break, and if not, I'll hear it. And either way, we'll make it work, because that's the name of the game, making it work. Even if you stumble into the show, you got to get up running. So we talked about the near-Earth objects that were coming up the list. We talked about the Humboldt Branch Observatory's near-Earth objects list. And now what I want to talk about, because I led into the show with a little bit of leading you on a pathway into space, so to speak, offering you suggestions to close your eyes and think about yourself and looking into space. This is what we're going to do. Keep doing that, because I'm going to list out the sky this week, October 26th to November 4th, what you might find when you look up to the sky. Saturday, October 27th, today. The evening will provide you with the final chance to see Jupiter before it disappears into the sun's glow. Hopefully, over the past 6 months, you've had an opportunity to see the arc of the planets play out across the southern skies. Now, I'm here outside of Houston, so I would go out into my backyard and I would be facing west, and over to my left-hand side, and in an arcing fashion or arcing pattern, played out the Venus, Jupiter, Saturn, Mars, Mercury, Moon pathways or observational positions that I hope everyone was able to enjoy over the last 6 months. But with this information, October 27th may be one of the last days that you can go out as the sun is setting and see Jupiter before it gets so low it's into the sunlight, too close to the sun for viewing. And then we will be left with Mars and I believe Saturn as well. Use binoculars to locate the giant planet 6 degrees above the southwestern horizon 30 minutes after sunset. Jupiter will shine brightly at a magnitude of 1.7. 1.7 is something you can see with your eyes. You don't need any assistance to see something that's 1.7 in magnitude. And it should be obvious if you have a clear and unobstructed horizon. As a bonus, you might also catch a glimpse of Mercury. Mercury isn't always so easy to find, and you can only find it in certain circumstances and under certain conditions. You have to have a clear shot of the horizon. In Texas we do, but we have a lot of trees and growth that does actually block the horizon. As a bonus, you should be able to see Mercury. The innermost planet lies 3.4 degrees above the horizon, about a half a binocular field below Jupiter, at magnitude -0.2. Mercury appears about 1/4 as bright as its companion. Look high in the southeast on October 28th. After darkness falls this week, and you should see autumn's most conspicuous star group, the Great Square of Pegasus. The Great Star of Pegasus stands out in the evening sky at this time of year, though it appears balanced on one corner and looks more diamond-shaped. These 4 almost equally bright stars from the body of Pegasus, the winged horse, the faintest star that represents the rest of this constellation, sharp trail off to the square's west. On Monday, October 29th, Mars continues to put on a great show these October evenings. If you look, in my instance, up and toward the south, you'll see the red planet with your eyes. It appears more than 30 degrees above the southern horizon once darkness falls. The world shines at a magnitude -0.7, significantly brighter than any star visible in October evenings. Against the faint backdrop of Capricornus, a telescope reveals a disk that spans 12 inches and shows several subtle surface features. On Facebook, I have a friend named Damian Peach. Unmatched, in my opinion, for images of Mars, Jupiter, Saturn. Damian Peach, he's the guy. You should like and follow to see amazing solar system captures of our planets. On Tuesday, October 30th, Uranus reached opposition and peak visibility 1 week ago, and it remains a tempting target all this week. The outer planet appears in the eastern sky after darkness falls and climbs highest in the south around midnight local daylight time. The magnitude 5.7 world lies in the southwestern corner of Aries, just over the border from Pisces, some 2.5 degrees northeast of 4th magnitude Omicron. Piscium. Although Uranus shines brightly enough to glimpse with the naked eye under a dark sky, use binoculars to locate it initially. A telescope reveals the planet's blue-green disk, which spans 3.7 degrees. Last quarter moon occurred, and this is for Halloween. Wednesday, October 31st, last quarter moon occurred at 12:40 p.m. EDT. By the time it rises in North America shortly after midnight local daylight time, its phase will have waned to approximately 40% lit. Earth's satellite lies near the border between Cancer, the crab, and Leo, the lion. The moon reaches perigee, the closest point in its orbit around Earth, at 4:23 p.m. EDT, and then lies 230,034 miles away from us. On Thursday, November 1st, the night sky's most conspicuous harbinger of winter now rises in the east around 11 p.m. local daylight time. That's the constellation Orion the Hunter. It appears on its side as it rises, with ruddy Betelgeuse to the left of the three-star belt and blue-white Rigel to the belt's right. As Orion climbs higher before dawn, the figure rotates so that Betelgeuse lies at the upper left and Rigel at the lower right of the constellation pattern. Friday, November 2nd, Saturn remains a tempting target in the early evening sky. The ring planet stands about 20 degrees and above the southwestern horizon an hour after sunset and remains on view until 9 p.m. local daylight time. Shining at a magnitude 0.6, it appears more than a full magnitude brighter than any of the background stars in its host constellation. Sagittarius, of course, the best views of Saturn come through a telescope, which reveals a 16-degree diameter globe surrounded by a spectacular ring system that spans 36 degrees and tilts 26 degrees to our line of sight. Although the calendar says November, on November 3rd, the summer triangle of bright stars remains prominent in the early evening. Look overhead after darkness falls and you'll spot Deneb, a conspicuous point of light, despite being the faintest of the three luminaries. Brightest Vega lies west of Deneb, and intermediate Altair appears to their south. On Sunday, November 4th, although Venus passed between the Sun and Earth just 9 days ago, its rapid orbital motion brings it back into view quickly. This morning, the planet rises an hour before the Sun and climbs 5 degrees high in the east-southeast 30 minutes before sunrise, so Venus is back. Shining at a magnitude negative 4.3, the brilliant world appears conspicuous against the twilight glow when viewed through a telescope. Venus displays a 59-inch diameter disk that is 3% illuminated. For those areas of the United States and Canada that observe daylight savings time, set your clocks back 1 hour this morning. The official switch occurs at 2 a.m. local daylight time, which becomes 1 a.m. local standard time. The switch means sunrise and sunset both arrive an hour early today than they did yesterday, so at least by clock time, the latest sunrise of the year occurred yesterday morning. I'm going to go back. That is for the description of Sunday, November 4th. It describes Venus coming back in the eastern sky. And then it says, for those areas of the United States and Canada that observe daylight savings time, set your clocks back 1 hour this morning. The official switch occurs at 2 a.m. local daylight time, which becomes 1 a.m. local standard time. The switch means sunrise and sunset both arrive an hour earlier today than they did yesterday, so at least by clock time, the latest sunrise of the year occurred yesterday morning. I want to take a second to read this short Wikipedia. The intro is plain and simple. Plasma cosmology. Plasma cosmology is a non-standard cosmology whose central postulate is that the dynamic of ionized gases and plasmas play important, if not dominant, roles in the physics of the universe beyond the solar system. In contrast, the current observations and models of cosmologists and astrophysicists explain the formation, development, and evolution of astronomical bodies and large-scale structures in the universe as influenced by gravity, including its formulation in Einstein's theory of general relativity and baryonic physics. Some theoretical concepts about plasma cosmology originated with Hans Alfvén, who tentatively proposed the use of plasma scaling to extrapolate the results of laboratory experiments in plasma physics observations and scale them over many orders of magnitude up to the largest observable objects in the universe. Cosmologists and astrophysicists who have evaluated plasma cosmology have rejected it because it does not match the observations of astrophysical phenomena as well as current cosmological theory. Very few papers support plasma cosmology have appeared in literature since the mid-1990s. The term plasma universe is sometimes used as a synonym for plasma cosmology. And see if I can make this happen. 5, 4, 3, 2.
0.5 plane wave, which is a 12.5-inch plane wave Dahl-Kirkham design. It's a corrected Dahl-Kirkham. That's the acronym CDK. It's from a company called Planewave, and it's F8. By the way, the Takahashi, the F ratio is 7.7 on it. On this Planewave, it's F8. The Takahashi has a reducer, so its actual ratio as I use it is F5.6. And then finally, last but not least, in terms of big OTAs, I have the Officina Stellari RH200 astrograph, which is a little over 8 inches at the front and is an F3, a native F3. So by mixing apertures and F ratios, we're able to fit and cameras, we're able to fit the observing session to the objects that we have in mind. And by having all three of them on the mount at the same time, I can rapidly change OTAs and cameras. I did happen to get a chance to look at. I got a chance to look at your setup. It's quite impressive. I want to say one thing about the 3 different telescopes that you have on there. For the listeners, what you get, I want to talk about field of view, right? Because I know that your Takahashi is a wide field, correct? Yes. And
then your other ones are smaller field of view, FOVs, correct?
Well, actually, in this case, the astrograph, since it's F3, is only 600, roughly 8 inches by 3. It's only 24 inches focal length. It has a very, very, very wide field.
It does?
Oh yeah, it's a very, very wide field instrument. I think it's the widest field I have. So that's one of the reasons I have it. It has a very flat, wide field. Then the Takahashi has the next level up of field width, and then finally the Planewave. And I'm going to let you talk about it. You please go ahead.
Well, I just wanted to give Chris. How you doing?
Mm-hmm. Not too bad, Francis.
I know that it's easy to just it's easy to sit back and get lulled. You get lulled into the equipment sometimes, don't you?
Yes, this is true. And I think what's important for your listeners to understand about focal ratio, they're probably wondering, what is focal ratio and focal length? And when we're doing near live observing, we're trying to get as fast focal ratio as possible. So what that means is the light will build faster so we can see the image sooner and less exposure time. And that's very important. And field of view does come in different sizes. And you are correct, Francis and Mark. There's so many things in the universe that are vary in size. Like there's a California nebula, for an example. That's huge. It's like the moon is half a degree. And I don't know, Mark, how many California moons would fit into the California nebula, but be quite a few. But we use different instruments because it varies. Now, if you're starting off just new in the field, it doesn't mean you have to jump in that deep. You can get yourself a small little refractor and a simple DSLR camera that you can buy for everyday photography, and start with that. Keep it simple, enjoy it, learn, and take your time. It's a fun hobby, Francis.
Well, it surely is, and I've been involved with it and had my own personal, I call it desire. I have a desire for astronomy, and most of it is based on being aware of what's going on in space, and it sometimes differs a little bit with the astro imaging portion, but I know that if I ever need to know the truth about something in space, I need to have access to a telescope so that I can point it into the night sky and point it at what I need to point it at and get a respectable picture back, you know?
Mm-hmm. Yep.
I had that experience so many years ago when I was dealing with comets, and I'm still dealing with comets, and I'm still currently, we have the search for Planet 9. Just last week I had a guest on Dr. Renu Mohatra, and I didn't know through all this discussion of Planet 9 that in her circle, it's not just a Planet 9, but there is a Planet 10. There's actually a Planet X that is an Earth or Venus-sized object that could be closer in toward Neptune and not be so far-flung as this Planet 9 would be. So for me, what that always tells me is that I need to have eyes on the skies. For the listeners who don't personally have a connection with astronomy yet want to know what's going on out in space, I can tell you that there's a large group, you know, the way that society is today, that people take time to go out and do some researching these days, and most people make up their own mind these days. And once they've made up their own mind, they are true to that thought. So for people who don't have access to telescopes, who don't have their only access to information about space may be given to them through media, and they may not necessarily like or trust their media that they're getting, the amateur astronomer has always been the well to go to. Because let me ask one question about this. How many images made up this image?
Okay, there were 5 10-minute exposures for 4 filters.
Okay, and this is how I want to connect some of our listeners to the type of astronomy that they may run into if they want to get their hands or feet wet on astronomy these days. What we have with Mark and Chris is near real-time astrophotography, where they take a series of images, they stack them, and then they'll produce for those who are viewing that image, right? And in this case, he used what is known as a Hubble palette to create the layers of colors in the image. It's a fantastically beautiful image.
Yeah,
any more?
Gorgeous.
Yeah, Chris, why don't you speak about what we were doing, how we did it?
Yes.
Okay, so what Mark was doing is he was using filters. The wavelengths are different. One was hydrogen alpha.
The HA.
Yeah, the HA. And he picked up, I believe it was 4 10-minute. Now, 10-minute means Mark was imaging with the camera shutter open for 10 full minutes, and to keep the stars nice and round, even though he's using a good mount, he was guiding, meaning
super
there's
guiding,
a separate,
right.
yes, and that makes sure that the mount, there's no errors and the stars are nice and round and tight. So he captured the HA, and then he went and did oxygen 3 captured
0111.
0111. 111,
yeah.
and he captured, I believe, 10-minute exposures, and a few of them again, 3 or 4 or 5 of them.
5.
Then
it was
5. Okay, and then he captured sulfur. It's S2.
S2.
Yeah, that's in the high red wavelength, and the oxygen is actually green, the green wavelength, and the HA is a lower red at about, I don't want to confuse the audience, but at 656 nanometers. That's a certain position on the wavelength chart. Right. And then he combined all the single images into a master HA, O3, S2, and then combine them 3 into forming a color image known as, in this palette, the Hubble palette.
So the Hubble palette.
The palette.
And this object here is the
Heart Nebula, known as the Heart Nebula. Yeah.
It actually looks like a heart in this picture, doesn't it? I could see that.
Yes,
I've never noticed
the heart to me is on its side though, correct?
Yes,
it's east-west, right?
Yeah,
correct. But I was mentioning to Mark yesterday about the fish, and they didn't see it. But if you look at the upper right corner, it looks like a fish there, or a dolphin.
You see the gill. You see the gill rim.
Yes,
and you might also, as you paint a word picture around the nebulosity and etching the shock waves, which are present in this gas, is where the sulfur 2 lives, and that's what I was discussing with Chris Francis when you came back. You can see how it outlines
the edge, the lighter edge.
Yeah. So a lot of people say, well, we'll just do bicolor. They'll use oxygen and hydrogen because hydrogen is the most dominant element in the universe, and when you image at hydrogen wavelengths,
it's kind of diffuse, though.
It's a big, it's diffuse, but it's a big signal. These other elements are much more rare, and they don't make a big signal. But if you don't do sulfur, you lose this. I think it's a wonderful contrasty definition of the edges kind of thing that I really personally find very attractive. So I tend to want to do sulfur, even if it's faint, because it adds a lot to the imaging. So, by the way, let me just say something about the Hubble palette. In the Hubble palette, they don't map by the actual color spectrum that the filters would render to your eye. They map hydrogen onto green, they map oxygen onto blue, and they map sulfur onto red. Yeah, and so that's what it means, the Hubble palette.
There you go. So it's attaching color schemes to different molecules that are out there.
Exactly.
And you'll end up with
the same one the Hubble telescope uses.
And if I can add, Francis, to your audience, last night we were doing these captures with filters known as narrowband, where they are very narrow and they cut out any light pollution. And with the moon out last night, creates a lot of light, the moon, and it can wash out the image and rob the contrast. So this is known as
strategy.
Narrow.
For the listeners, this is how it goes. There's never enough time for astro imaging.
True.
And so when you say that, you have to schedule and have a strategy. And what that means is if there's a night where there's some more moon than you would like to do a straight luminance filter, then you're better off using these narrow band filters, and then that way you'll be using your time more wisely.
That's correct.
Again, there's never enough time because gentlemen, I know. Well, let's put it this way: even if every astronomer didn't want to do anything but astronomy, they would eventually have to take a break sometime during the day. But because we have this wonderful round globe that we live on, there's always an astronomer who will be in the perfect situation and have plenty enough energy to point a telescope out in the sky and to give us images. Well, how are we going to see his images, you may ask? Well, that's why we have wonderful places like NightSkiesNetwork.com, Facebook.com, Flickr, Instagram. all the social medias, because you know why? The amateur astronomers aren't just amateur astronomying, and that's not a word, but I'm saying amateur astronomying for themselves and curling up in the corner and hoarding all their pictures. Why people do it is to share. And as technology gets better and better, we as humans have to improve our techniques. And gentlemen like Chris and Mark, if you haven't been able to tell, they work very good together.
Yeah, we definitely love sharing with everybody. So you're welcome to join us anytime. And we've all become friends. Mark and myself have known each other for many, many years, and we get along. And that's the beauty about astronomy. It opens the doors for everybody to join in.
Yeah, as a matter of fact, Chris, I think you were my first acquaintance in the world of broadcast astronomy. I actually believe that you were the first person I talked to, and I think we immediately bonded. And I remember spending very late nights with you when you were acting crazy and staying up till 5 a.m. Canada time, and
freezing in the winter.
it was late for me. So yeah, we've been doing this a while.
Thank you.
One thing I'd like to say, Francis, for your audience, is that they can begin with a pair of department store binoculars.
Yes.
And have a fantastic, wonderful experience that is just as, in some ways, more immediate and more impactful.
Awe-inspiring.
Yes. And they need to do that. They need to.
Yeah. And that's why I try to promote space. I try to inform about what's going on relevant to this time frame around right now, because again, now is the only thing that we can affect in our lives is right now. So I try to give some news about things that are going on around now, and hopefully that'll take listeners and give them a reason to go out in their backyard or out to the field and point their eyes toward the night sky on a clear night and see wonderful things. Because in my opinion, the space is still the closest place to find things that have never been discovered before. And that for one person may be something like a nebula that may have been cataloged a long time ago, but the first time you get to witness something like this heart that I'm looking at right here, created by Mark with his tools, it takes your breath away. And I will say, in my opinion, 10 years ago, we weren't. I don't think in normal, maybe 10 years, because I think it's been a decade now that we've really been pushing up this technology. But you can't go back too far and find the same quality of images readily available to the public like they are right now. Now, I heard during the break, Chris was talking to Mark. Mark, are you going to broadcast tonight?
Yes, I am.
Are you going to broadcast on the Night Skies Network?
Yes, I am. I'll be on Night Skies.
Okay, so everyone, it's going to be a while because you're in California. You still have a number of almost 4 hours or so before the sun sets, a couple of hours, 3 hours. So for those folks who are listening to the show and going to be sitting around wherever they may be, go to the nightskiesnetwork.com. You can get a free membership there. Joe Sardina, tell Joe we sent you. We'll be sure to make sure that you have a way to get onto his network to see what astronomers like Mark and Chris are working on. You'll hear the collaboration. They have a chat room that's active, and once the show starts, me and Bob have we've done some great shows on there. Bob's done great shows. It's fun. It's fun to watch. It's fun to do a show. It's fun to watch people come into the chat room and interact. It's fun to hear and listen and watch the interactions amongst the astronomers as they help and guide and collaborate. And you can hear it in between Mark and Chris, the connection that they have. It's a connection I wish all my listeners had with astronomy, because it's something that takes us to a good place. And think about get your mind sometimes off of what's down here under the atmosphere. Take your head outside into the clouds and see what's out in space. Gentlemen, I've had you now for about 45 minutes, coming up on an hour. I think I'll let you go. I think we can end now, and then that way, if there's anything that I held back on, we can talk about again in the future.
That sounds good, Francis.
I'll give you both back your life. I thank you so much.
Thank you very much. I really enjoyed it.
I thank you for your time.
Thanks for having us.
You're very welcome.
Okay.
Very welcome. I think if you just read, hang up on me and we'll be done. Thank you very much, Chris. Bye, Mark. Okay, everyone, it's Collision Course. We had our Amateur Astronomer Night in America on Collision Course. It wasn't perfect, but I really did enjoy having Mark and Chris. Two gentlemen who work closely together, collaborating on imaging space, nebulas, galaxies. NightSkiesNetwork.com. NightSkiesNetwork.com. It's one place a community already goes to witness astronomers as they look into space at objects that you can be quite amazed at. I'm also going to mention that I use a robotic telescope network, itelescope.net. That may be for use by listeners who do not have a telescope but really, really wish they could get their hands on a telescope. And you don't physically get your hands on one. You get one through your internet connection and your computer. You're able to access and control telescopes through itelescope.net, to which you may want to know something about a certain object or a certain place in space, and you need to know right now. You can go and get that access. I've done it many times. I'm doing it right now with the Citizen Space Force. The Citizen Space Force is working hard on 3, 4, and 5 missions now. The fleet is grown, and the work is going to continue. Invest areas are ready to be uncovered and are already being uncovered at this moment. For astronomers, though, we're going to continue this with Amateur Astronomers Night in America on Collision Course, and we're going to talk about some of the objects that astronomers like Chris and Mark may be looking at. Maybe you're an astronomer, amateur or otherwise, and you're going to be wondering what's out in space in November. November's finest 50 finest deep sky objects. Right off the bat, we're going to start with NGC 925, the Triangulum, attractive face-on barred spiral galaxy, glows at a magnitude of 10.1 and measured 12 inches by 7.4 degrees. To find it, point your telescope 2 degrees east of Gamma. Y trianguli. Through a small scope, NGC 925's figure appears indistinct, but an 8-inch or larger instrument reveals the spiral arms that fold back abruptly from a long bar at high magnification. Say above 250 times, you'll spot the stellar nucleus. NGC 925 Triangulum, 50 items in the November night sky. NGC 891 Andromeda, that is the Milky Way's partner, the future collision between Andromeda and the Milky Way. NGC 891's only problem is that it's NGC 891's only problem is that it's Andromeda's second best galaxy. Not bad, except the constellation's top dog is one of the sky's supreme wonders, the Andromeda Galaxy M31. So this isn't M31, this is NGC 891 Andromeda. The only problem is that Andromeda's second best galaxy. The Andromeda Galaxy M31, despite that, NGC 891, also known as the Silver Sliver Galaxy, ranks as one of the sky's best edge-on spirals. Next, NGC 908 Cetus. To find the spiral galaxy, look 5.4 degrees east of Epsilon Ceti through an 8-inch telescope, magnitude 10.4. NGC 908 appears as an oval haze 5.9 by 2.3, stretched roughly east to west. The core is quite a bit brighter, and ghostly hints of spiral structure appear at high magnifications. Next item, Polaris, Ursa Minor. The first double star on this list is the North Star. William Herschel discovered that Polaris was binary in 1780. Although the yellow magnitude 2.0 primary outshines the blue magnitude 9.0 secondary by more than 600 times, the separation is a worthy 18.3, so a 3-inch telescope at 100 times easily will show you Polaris B. Next item. NGC 956 Andromeda. The magnitude 8.9 open cluster lies 5 degrees east-northeast of Almach Gamma Andromeda. This odd group has 9th magnitude star at both its north and south end, a couple more 10th magnitude stars, and about a dozen magnitude 12 and fainter stars. It spans 6 degrees. Next, NGC 957 Perseus, the open cluster, which glows at a magnitude of 7.6 and spans 10, lies about 1.5 degrees east-northeast of the famous double cluster. Through an 8-inch scope at 100 times magnitude, you'll count 24 stars. A magnitude 8.0 star sits slightly southeast of the cluster center. At the cluster's southwestern edge, it sits a magnitude 8.5 star. Next, IC 1805 Cassiopeia. Because this object is also known as the Heart Nebula, has a diameter of 1 degree, you can approach observing it either with low or high magnification. Each requires at least an 8-inch telescope in a dark sky. Look at 4.9 degrees east-southeast of Epsilon C Cassiopeia. For an overall view, insert a nebula filter and identify the Heart's brightest region, the central cluster, the knot of nebulosity to the east, and the crescent of gas to the southwest. NGC 1027, a magnitude 6.7 open cluster, shines 1.2 degrees east of the nebula and spans 15. Another bright nebula known nebulous knot, NGC 896, lies 1 degree southwest of the Heart. Many observers see this 20-wide object before they spot IC 1805. The Fornax dwarf Fornax. Although the Fornax dwarf galaxy's stated magnitude is 8.1, its size, 12 by 10.2, makes its surface brightness low. That said, it's spotted through a 4-inch refractor using a wide-angle eyepiece. Through an 8-inch scope, choose an eyepiece that yields a 1-degree field of view and slowly sweep the area. You're looking for a faint haze, just brighter than the background sky. Once you've located the Fornax dwarf, crank up the magnification and aim for its northern edge. There sits globular cluster NGC 1049. This object shines at magnitude 12.6 and measures roughly 1.2 across. NGC 1023 Perseus, the magnitude 9.3 spiral galaxy known as the Perseus lenticular, measures more than twice as long as it is wide, 8.6 by 4.2, stretching in a rough east-west direction. Through small telescopes, the core appears almost star-like. Use a 14-inch or larger scope, however, and you'll see that the central region spans half of the galaxy's overall length. NGC 1027 Cassiopeia, you'll find this nice open cluster not quite 6 degrees east-southeast of Epsilon Cassiopeia. It glows at a magnitude 6.7 and spans 15. Through an 8-inch telescope at 100 times, you'll see the brightest 15 or so members in front of a haze of fainter stars. A 12-inch scope resolves about 20 more stars. A magnitude 7.0 star glows at the heart of NGC 1027. NGC 1052 Cetus. At the eastern edge of Cetus 3.8 west of Eta Eridani lies a nice trio of galaxies highlighted by magnitude 10.5 NGC 1052. Through an 8-inch telescope, it appears overall 2.5 by 2.0, with an extended central region surrounded by a slight haze. Only 15 to the southwest lies the magnitude 11 spiral NGC 1042. It is more than 50% bigger than NGC 1052, but you'll need at least a 16-inch scope to bring out any trace of the arms. Even fainter is the magnitude 12.2 NGC 1035, 23 northeast of NGC 1042. This galaxy is 3 times as long as it is wide, but doesn't show details through most scopes. Use a magnification around 100 times to catch all 3 galaxies at once. NGC 1055 Cetus. Look 39 east of Delta Ceti, and you'll find this magnitude 10.6 spiral galaxy. Through a 6-inch telescope, it appears twice as long as wide, and aligned nearly east-west. Just to the north of the galaxy, you'll find a magnitude 11.2 star. M34 Perseus. From a dark site, you'll find the spiral cluster with your naked eyes roughly 5 degrees west-northwest of Algol. Beta Persei. At magnitude 5.2, it contains 10 stars brighter than 9th magnitude, spread out over an area 35 across. A 4-inch scope reveals 36 member stars between 8 and 12th magnitude. At 100 times, look for the chains of faint stars crisscrossing the field of view. M77 Cetus A, the first strong radio source discovered in this constellation, lies 0.9 degrees east-southeast of Delta Ceti, the galaxy's central area. 1/3 its width will command your attention, although you can spot M77, which glows at magnitude 8.9 and measures 8.2 by 7.3 through any telescope. An 11-inch or larger instrument and a magnification of 300 times will let it put on a show. Ignore the bright core and search the disk surrounding it for signs of mottled structure. Look for a tightly worn spiral arms. The brightest one lies southeast of the core. Kafalgidma Cetus. Kafalgidma Cetus. This colorful double, also known as Gamma Ceti, is a bit puzzling. The magnitude 3.5 primary appears white or just a bit yellow. There's not much to dispute about that. Lying 2.8 away, however, the magnitude 7.3 companion should not appear the shade of blue most observers report. It's a spectral class F star, which is hotter and therefore should be just a bit wider than our sun. What color do you see? NGC 1097 Fornax. Our next object is a magnitude 9.2 barred spiral that sits 2 degrees north of Beta Fornacis. Through an 8-inch telescope, you'll see NGC 1097's core as a bright disk surrounded by an oval haze. Within that oval is the galaxy's faint bar. You won't see much of the thin spiral arms no matter what scope you observe through. This system measures 10.5 degrees by 6.3. IC 1848 Cassiopeia. The Baby or Soul Nebula sits 2.5 degrees east-southeast of the Heart Nebula, IC 1805. Although equally as wide, 1 degree, as the Heart, the Baby doesn't cover as much area, so it appears more concentrated. A nebula filtered view shows 2 large regions that form the head and body. The head appears denser, while the body surrounds a small cluster within. To see the stars better, remove the nebula filter. Through a 12-inch or larger scope, you'll notice brightness differences along the body's edge. Look for 2 crescent-shaped nebulae, a smaller one to the northeast and a larger one to the west. NGC 1232 Eridanus. Although a 4-inch telescope will reveal magnitude 10.0 NGC 1232, I recommend instruments with at least 12 inches of aperture. Seeing the steadiness of the air above your observing site is the key to discerning the individual spiral arms. Can you see 3, 4, more? It all depends on your seeing. NGC 1232 isn't quite round. It measures 6.8 by 5.6. Through a large telescope, this galaxy's nucleus has a slight east-west elongation, which puts it in the barred spiral category. NGC 1245 Perseus. To find NGC 1245, which glows at a magnitude 8.4, draw a line between Lambda and Kappa Persei. This nice cluster lies less than 1 degree east of the line's center point. Through an
The opinions expressed on this radio station, its programs, and its website by the hosts, guests, and call-in listeners or chatters are solely the opinions of the original source who expressed them. They do not necessarily represent the opinions of Revolution Radio and FreedomSlips.com, its staff, or affiliates. You're listening to Revolution Radio, FreedomSlips.com, 100% listener-supported radio, and now we return you to your host.
Hey everyone, it's Francis. The last half hour, Collision Course episode 4. We had our weekly stumbles, but we're going to bring it home. Thank you for listening. We want you to continue listening to Collision Course every Saturday night from 6 to 8 p.m. Eastern on Revolution Radio or at freedomslips.com. We want our listeners to know that this is a wholly listener-supported radio station. Without your support, the station will not be able to function, will not be able to continue to operate. Revolution Radio at freedomslips.com, revolution.radio is a place for free speech. There's got to be over 50 or 60 different individual radio talk shows where you can come and listen to ideas across the spectrum. You can find something that you'll like here on Revolution Radio. And if you do come and find something you like, come back. And if you really like it, take time to press the donate button, go to the resource page, purchase something there at the resource page. Could be seeds, could be silver. Support the radio station. Without radio stations like this, we lose our voice. Even if they're stumbling in and out of their show, the hosts do often have something to say that's important. Depending on their topics, they should be able to refer to you some good news. Myself, I was working through the top 50 November deep sky objects. I want to look through our other list. There was a quick note that today the NASA Johnson Space Center had an open house celebrating the 60th anniversary, celebrating NASA's 60th anniversary and the International Space Station's 20th anniversary. So the NASA's Johnson Space Center had an open house. That's important because we live in the area. Myself, my family live it's quite a distance away, but we're down here in Houston, so NASA's Johnson Space Center plays a big role in the Houston area. October 27th, it was an open house from 10 a.m. to 2 p.m., and they got a behind-the-scenes look at current, past, and future projects for NASA, including their missions, their manned missions into space. Here's something that really piqued my interest. I saw the article. Let's go back to the original article if I can find it. This is all about China sending up moons to help illuminate over land. So here's the first article. China is launching a fake extra bright moon to cut the cost of city lights. In a move that sounds straight out of a sci-fi paperback, China is planning to launch the first artificial moon into orbit in order to replace streetlights and reduce energy costs. Chinese scientists say the man-made moon, which is essentially an illuminated satellite, will be in orbit by 2020. It will be 8 times brighter than Earth's moon and will shine down on the city of Chengdu, the capital of the southwestern Sichuan province. It is hoped that innovation will replace the need for streetlights and will reduce annual electricity costs by up to 1.2 billion yuan, or 173 million. Residents shouldn't worry that it will light up the entire night sky. Wu Shanfeng, chief of the Tianfu New Area Science Society, said to China Daily, its expected brightness in the eyes of humans is around 1/5 of normal streetlights. He said, adding that it could even assist emergency services during blackouts and natural disasters. The moon will only illuminate a 50 square kilometer area as it's much closer to Earth than our real moon. It will sit about 500 kilometers, 310 miles away compared to the moon's 380 kilometers or 236,000 miles. If the project proves successful, China plans to launch 3 more moons around the country by 2022. The first moon will be experimental, but the 3 moons in 2022 will be the real deal, with great civic and commercial potential, Wu said. Before it makes its city debut, however, the moon will have to be tested in an uninhabited desert so that its light beams don't interfere with people or Earth-based space observation equipment. That was one thing I didn't get to talk with Mark and Chris about, was light pollution. Let's look at this new one. So this is the latest article. China is launching artificial moons in urban areas. Forget streetlights. One Chinese city may soon rely on an artificial satellite to light its nighttime sky. See how they propose this one in this article. In one Chinese city, costly streetlights could soon be the thing of the past. By 2020, the Tianfu New Area Science Society plans to launch an artificial moon to light up the night sky. If the plan goes through, the so-called illumination satellite would orbit above the Chinese city of Chengdu and glow in conjunction with the actual moon, but shine 8 times brighter. The organization says it will launch 3 more satellites in 2022, potentially replacing streetlights in urban areas. The plans were announced by Wu Chengfeng, head of the society, at an innovation conference in Chengdu on October 10th. Chengfeng told China Daily that the satellites launched by the Xinjiang Satellite Launch Center will orbit about 300 miles above the city and use its mirror-like coating to reflect sunlight down to Earth. Despite shining light in a similar way, the satellite boasts one advantage that the moon doesn't: human control. Chengfeng said that both the location and brightness of the human-made moon can be changed, and that it can be completely shut off if necessary. And since the satellite is mobile, it can assist in disaster relief by beaming light on areas that lost power. Cutting costs. The lunar project aims to cut down on costly streetlights in China's bustling cities. By lighting up just 31 square miles, or 50 square kilometers, of Chengdu's night sky, the mini-moon could save the city an estimated 1.2 billion yuan, or 174 million each year. The 3 follow-up moons, though, will be able to cover much more ground. The trio will take turns based on who's facing the sun, beaming light on the city streets. Working together, they'll be able to illuminate 2,000 to 4,000 square miles, 3,600 to 6,400 square kilometers for up to 24 hours. Plans, potential pitfalls. Plans this big are bound to be met with some apprehension, and the mini-moons are no exception. In the 1990s, an unsuccessful attempt was made by the Russian Federal Space Agency to launch similar reflective orbiters. After one of their satellites failed during deployment, they ended up scrapping the project. Chengfeng also said that people have concerns about the moon's impact on the sleep patterns of humans and animals, but from the sounds of it, the group thinks that the burden will be minimal. We only conduct our tests in an uninhabited desert, so our light beams will not interfere with any people or Earth-based space observation equipment. Chengfeng told China Daily, when the satellite is in operation, people will see only a bright star above and not a giant moon as imagined. Apprehension aside, the mission could pioneer a new wave of space energy usage if it ends up being successful, and if not, we'll at least have a few extra moons to gaze up at. Well, isn't that something? They're going to put up some satellites. They're going to be reflective. They're going to reflect sunlight back onto their country, China, city, Chengdu, and they're going to save millions and billions of yuan doing it. I wonder if somebody will go blind looking directly at the satellite. But they say that it's not so much light that it's brilliant. It's just enough light, 8 times brighter than the moon. But I wonder if you were to have a reflective satellite that had magnification involved with its mirror, which I'm sure they will, they can magnify whatever reflective sunlight they're dealing with and potentially increase the magnitude of sunlight that hits the ground and maybe really create a day out of night. They could potentially create day out of night if and when they needed. If they wanted to illuminate an enemy, if they wanted to do things like that, maybe they could. Maybe it's going to be a good thing for the city, and that's just that. We'll have to wait. It's going to be happening over the next couple of years. China's going to launch some artificial moons to capture the light of the sun when the sun isn't up. Try to do that, flat earthers. How are you going to Good point, Francis. How are you going to figure that, flat earthers? Figure that one out. All right, the next thing on our list. Astronomers find a universal correlation that could unify the study of star formation. There's a lot of talk about star formation these days. Is it accretion? Is it gravity? Is it gas? Is it gravity? Is it pressure? Is it electricity? Birkin. Okay, I am on physics.org. Maybe I can actually share this one since I had the time. I'm just going to go in there and drop it. I'm going to drop one link into the chat. Come on. Maybe not. See we chat one more time. Come on. Come on. Capture. Paste. No. Well, this is on physics.org/news/2018-10-universal-star-formation.html. We can follow it that way. Astronomers find a universal correlation that could unify the study of star formation. Star formation is one of the most important research fields in astrophysics, the process in which gravitational instabilities cause the collapse of gas to form more compact structures and finally stars. And of course, there's going to be a large segment of people who are just not going to agree with this, but we're just going to go with it. Encompassing a broad range of physical scales. These include star-forming galaxies on the large scale, individual young stars with envelopes and circumstellar disks on the smaller scale, and intermediate scales that include giant molecular clouds and protostellar cores. In the last decades of the 20th century, astronomers established a well-known star formation relation for the intermediate large scales called the Kennicutt-Schmidt law. More recent versions of this law established that the so-called star formation rate, SFR, which measures the pace at which stars are formed in a galaxy or a molecular cloud, is proportional to the amount of dense gas mass present in that galaxy or molecular cloud. The previous relation confirms that the star formation rate measured in galaxies is related to the mass of gas that is transformed into stars, which are located in the molecular clouds that those galaxies host, given that it is here where the material that will form stars is found. On the other hand, at the small scale of star formation, it is also known that there is a correlation between the mass accretion rate, which measures the pace at which circumstellar gas falls onto a star in formation, and the mass of the protoplanetary disks that surround young stars. It is only recently that this second correlation has been confirmed observationally, at least in the star-forming regions where both parameters have been measured accurately. In a work recently published in the Astronomy and Astrophysics Journal and led by researchers Ignacio Mendigutia and authors, have compiled the available data for the SFRs and the dense gas masses of a sample of galaxies and a representative group of molecular clouds within the Milky Way, and the available data for the accretion rates and disk masses of a representative sample of young stars also in our galaxy. What they have found is surprising. A unique correlation emerges between the data compiled, encompassing no less than 16 orders of magnitude and relating very different physical scales, individual, young stars, molecular clouds, and galaxies. Mendigutia said, "We have found a correlation between the pace at which gas transforms into stars and the dense gas mass directly associated to star formation. This is probably one of the wildest empirical relations ever observed." Let me say that again. This is probably one of the widest, not wildest, but widest empirical relations ever observed, given that it encompasses an enormous range of scales, from sizes of hundreds of thousands of light years in galaxies to sizes comparable to our solar system in stars. The researcher suggests a bottom-up hypothesis to explain this discovery and propose future observations to test it. According to their hypothesis, the correlation in galaxies and molecular clouds would result from the smaller scale relation between individual stars hosted by them. After the initial surprise, the fact that what we observe in individual stars correlates with whole galaxies is what one would expect if measurements on both scales are correct, concludes Mendigutia. So what they're finding is a correlation between mass, size, mass and the size of the molecular cloud. You must have a certain size of molecular cloud in order to acquire the accretion required to create a number and size of a star. We're going to follow up on this universal correlation that could unify the study of star formation as they build their base of evidence pointing toward a correlation of mass and structure with the nebulosity and gases in a nebulosity. One more physics, because this is really out of this world. And this is the type of study and research that will take us from here to a very distant place without the use of a transport. This will just be a procedure for transportation rather than an actual transport, the need for a transport. Beyond electronics, future computing devices could rely on the manipulation of quantum states of light confined within nanoscale structures. Researchers demonstrated that matching the photon states to the basic symmetries of the structure can help preserve the crucial quantum information, which means they're sending something from here to there at the same time or while maintaining its integrity informationally. Because as we are, as human beings, we're a bunch of information. If we want to jump into a wormhole, we need to have our information as we know it get to that place over there in the same way. And though your particles may be scrambled, they'll have to know how to get back to the original form. And entangled particles is going to be one way that they're going to do that. What you have an entangled particle can be two particles, a single particle that can be in two places and identical and acting exactly the same in two different locations. They're called entangled particles. Future quantum computing devices may include a nanoscale waveguides for light, but the quantum information stored in waves passing through such structures could be disturbed as the light interacts with the surrounding material. So the goal is to exchange information without any information loss. Starting with the simpler case of light passing through a tiny hole, researchers have now shown how to engineer quantum states of two photons that are protected by fundamental physical principles and pass through unchanged. So that's really a statement. The work should help in finding ways to keep delicate quantum information from being destroyed in future nanoscale chips. And this is all about quantum computers, but this can also be quickly. We are technically a quantum type computer working on a different temperature, which limits our ability. Though we have an enormous amount of computing power, we were only using 10% of our computer because of our environmental state of the computer hardware. But researchers building devices to control and process quantum information often use photons to store data. It's easy to use stable physical properties of light, such as photon and photon polarization, the configuration of the photon's electric field, to encode digital bits, such as 0 or 1. However, light often interacts strongly with nanoscale devices, especially those having features smaller than the light's wavelength. So these devices can modify photonic bits in unexpected ways, negatively. To address this concern, researchers are seeking other properties of light that might be more stable. As Gabriel Molina Teresa of the Donostia International Physics Center in San Sebastian, Spain notes, one way to find such properties is by using basic symmetries. A circular hole, for example, has both rotational and mirror symmetry and can serve as a prototype for testing the interactions between light and a nanostructure. Quantum states of photons can be engineered to share symmetries of a circle, and in principle, even if the interaction with the hole alters the state, changes its wave function, the state symmetry should not change. It turns out that for one particular type of symmetry, the so-called antisymmetric symmetry, where the wave function changes signs under rotation and mirror reflection, there is only one possible state, so symmetry protection becomes state protection. The state cannot be altered at all, no matter how complex the interactions might be. In experiments, Molina, Teresa, and colleagues have now demonstrated the protective effects of symmetry. They fashioned a nanoscale aperture, 750 nanometers across, in a metallic sheet, and then created several types of entangled photon pairs, each described by a different wave function. While one of these states was the perfectly antisymmetric state, other states were not. The team found that the antisymmetric state was preserved when passing through the hole, while the other states were strongly altered. There were experiments showing that the entanglement was not preserved when photons were transmitted through a nano aperture, said Molina Teresa. We've shown that you can protect the entanglement by using the right symmetry in the initial state. The achievements he suggests provides a new avenue for exploring so-called quantum plasmonics, the behavior of quantum states of light when confined in metallic structures on the scale of atoms and molecules. In this regime, light interacts strongly with plasmons. The wave-like motions of electrons in a metal, future development, Molina Teresa suggests, may go in various directions, depending on the purpose being pursued. For example, carrying out logical operations or transporting photons reliably from one part of a device to another. This paper is quite exciting, says solid-state physicist Karsten Rockstuhl of the Karlsruhe Institute of Technology in Germany. Previous research suggested that preserving quantum states of light requires reducing its confinement in a nanostructure, or giving it more space, he says. But here the author demonstrates a completely different mechanism by using symmetry. The research may also find uses in other areas of quantum technology, says Molina Teresa. Powerful methods for detecting the presence of single molecules, such as biomarker protein for cancer, exploit the strong focusing of photons that can occur in plasmonic nanoaperture. Detection can be made still more accurate by using entangled photons, but this requires a means to ensure the entanglement will be preserved as the photon travels to the biomolecule in the center of the aperture. This research was published in the Physical Review Letters. Mark Buchanan. It's important. Quantum mechanics, particles, antisymmetry, their adaptation, or science's adaptation of this technology is going to be the future of where our technology is taking the human race. We are right now building, we already have quantum computers available, Kindred AI,
Thank you for listening to Revolution Radio at freedomslips.com. Any commercial advertising you may hear in this program is of the sole discretion and benefit of the host of this program you are listening to. Revolution Radio does not endorse any commercial products, nor does it accept monetary compensation for on-air advertising of commercial products, nor will it ever. We are and shall remain 100% listener supported. Any product